Although they're manufactured by various suppliers, all international power steering pumps are vane-type pumps, either belt or gear-driven. The pumps on most current production vehicles are gear-driven. The main components of a pump are the pump drive shaft, rotor, cam ring, vanes, valve spring and spool, the pilot poppet, and the pressure and delivery ports. The pump creates a partial vacuum at the inlet, which causes atmospheric pressure to force power steering fluid into the pump from the reservoir. The pump then pushes this fluid into the system to power the steering gear. The pressure and flow ratio of the pump depends on vehicle application. Let's take a closer look at how it works. The pump's rotor is driven within the cam ring by the drive shaft, which is connected to the engine. As the rotor turns, the vanes spin along the oval inner surface of the cam ring with a varying amount of offset from the rotor's center. The spinning causes the chamber between the vanes to expand as the vanes pass the inlet section of the ring. This creates a low pressure condition, which forces hydraulic fluid into the chambers. This fluid is trapped between the vanes and carried past the large diameter of the ring. As the fluid approaches the outlet section, the ring diameter decreases, forcing the fluid out into the system. Within the vane slots of the rotor, system pressure is routed to the backside of each vane. This action forces the vanes outward, keeping them sealed against the cam ring during normal pump operation. The pump cam ring is shaped so that the two pumping chambers are formed exactly opposed to each other. Hydraulic forces cancel each other out and don't impose side loading on the shaft. The pump has a pilot-operated integral flow control and relief valve on the cover. An opening in the valve determines maximum pump delivery and system pressure. When the relief valve opens, the fluid is bypassed to the reservoir on a 3-line pump design, or recirculated to the pump inlet on a 2-line design. This limits the system to a prescribed maximum pressure. During low speed, the total pump delivery can be passed through the opening. Pressure in this chamber equalizes pressure at the other end of the relief valve spool. The light spring holds the spool closed, and fluid from the pump is blocked from the tank port by the spool land. When pump delivery is more than the opening allows, a pressure buildup forces the spool open against the light spring. Extra fluid is forced past the spool to the inlet port. If pressure in the system builds up to the relief valve setting, the pilot poppet is forced off its seat. Fluid in the large spring chamber flows through the spool and out to the tank. This causes a pressure differential on the spool, shifting it against the light spring. All the fluid can then flow to the tank. Vane pumps are built to close tolerances. Any contamination will cause damage that can lead to pump failure. For example, particles of dirt or sand in the fluid are abrasive and will score or wear the pump's closely fitted parts. Fluid contaminated with water or other liquids can rust the pump parts and housing. Rust will not only build up on the metal, but will also flake off into the fluid. All of these contaminants cause extra wear on parts, increasing the chances of internal leakage and reducing the pump's efficiency. Sludge is created when fluid reacts with excessive temperature changes or condensation. It can build up on the internal parts and eventually plug the pump. The heat and friction could cause the pump parts to seize. Air, water, and heat can also create sludge through oxidation. To ensure a contaminant-free environment, the fluid and filter should be changed according to the lubrication tables in the operator's manual. Always use the recommended fluid for the vehicle you are working on. Thin or worn-out fluid can be the result of extended drain intervals. Using the wrong type of fluid can cause many of the same conditions as thin fluid, including increased pump wear due to inadequate lubrication, leading to a loss of power assist, and reduced system pressure, also leading to a loss of power assist. Improper maintenance techniques, such as failure to change the fluid and filter at the prescribed intervals, can cause the fluid to become too thick, potentially leading to increased internal friction, which in turn will increase flow resistance through the system. Increased temperature, which increases the chance of sludge buildup. And finally, more power will be required for operation. The chemicals that make up some fluids can react unfavorably with the fibers or synthetic materials used in the pump packing and seals. This can lead to rapid deterioration, swelling, or shrinking of the seals and packings, resulting in both internal and external leakage. It is important that you refer to the operator's manual or ISIS for proper fluid type. Poor maintenance and contaminated fluid can also lead to poor pump operation, resulting in pump cavitation. Cavitation occurs when the fluid does not entirely fill the pump as designed. The more common causes of cavitation are improper bleeding, air leakage on the suction side, or low fluid. A pump that is allowed to continually cavitate will develop seriously worn parts, sluggish or erratic operation, and loss of power steering assist. Eventually, the pump parts may seize. Another cause of cavitation is substituting a hose that is smaller in diameter than the original, which leads to excessive back pressure or pressure loss. This in turn allows air bubbles to form and create excessive heat, eventually causing the pump and seals to fail. Using a hose made of material that doesn't meet system standards could also cause problems. For example, an inadequate hose might burst or collapse, depending on whether it was installed on the pressure or suction side of the pump. Consequently, International recommends the use of only OEM-approved hoses and fittings. This concludes Program 1 of the Power Steering Training Series. Completion of this educational process is a key component toward International Technician Certification. You are now required to take a post-test via ISIS, Education, Service, online testing.